In this video, I'll cover the last method that we will learn to solve a quadratic equation, and that is applying the quadratic formula. The quadratic formula states if ax squared plus bx plus c equals 0, with a not equal to 0, then the solutions of the equation are x equals negative b plus or minus the square root of the expression b squared minus 4ac, and that whole expression is divided by 2 times a. So this shows that the solutions of the equation are based on the values of a, b, and c, where a, b, and c are the coefficient of the quadratic term, coefficient of the linear term, and the constant term, respectively. Where does this equation come from, or where does this formula come from? Well, it actually comes from if we take the equation ax squared plus bx plus c equals 0 in its general form, and we apply the steps of completing the square to it. And I did this in the text, so I won't go through all the details here, but just to get you started in thinking, we would first have to divide everything by a. And so we would get this x squared plus b divided by ax plus c over a is equal to 0. And then we would have to move the constant to the right-hand side by subtracting c divided by a. And then we would have to take half of b over a and square it. So half of b over a is b over 2a, right? Really, half means to multiply by 1/2. So half of b over a is b over 2a. And then when we square it, we get b squared over 4a squared. And we would add that expression to each side. And so the left-hand side actually factors as x plus the expression we just squared to get the b squared over 4a squared, which is b over 2a. And on the right-hand side, we would have to combine those rational expressions, those fractional expressions, by getting a common denominator. I said I wasn't going to go through all this, but I am. You can fast forward this if you don't care about how to derive the quadratic formula, but notice that if we have negative c over a plus b squared over 4a squared, the common denominator is 4a squared. And so to be able to add these, I have to convert the negative c over a to a denominator of 4a squared. And so we would say a goes into 4a squared, 4a times negative c would be negative 4ac. So you can actually see where this b squared minus 4ac comes, because when we add those, we now can combine them by adding the numerators. Negative 4ac plus b squared can be written as b squared minus 4ac, and that's all divided by 4a squared. And then we would apply the square root property to get x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac, all divided by 4a squared. But we can subtract the negative b over 2a, and when we apply the radical to this fraction, we would have plus or minus the square root of b squared minus 4ac. But then in the denominator, the square root of 4a squared is just 2a. And then we can combine these to get the quadratic formula. So you don't have to know all of these steps. I think it's a good idea to have an idea of where it comes from, but you won't have to replicate this on a test. But these steps of completing the square produce this formula, which now enables us to use a formula without having to do completing the square on all of those equations. So let's look at this equation now. 3x squared minus 4x equals 4, and we want to solve this using the quadratic formula. So the first step is to write the equation in standard form by subtracting 4 from each side. 3x squared minus 4x minus 4 equals 0. Now, if you just were looking at this equation, you had the choice of, maybe I want to see if it factors. I can't do, I can't apply the square root property because of the x variable in it. Completing the square I could, but then I'd have to divide by 3, and then I'd have to take half of that fraction and square it. I'd get ugly numbers. So I think the practical solution would be to use the quadratic formula. A is 3, B is negative 4, and C is also negative 4. So the quadratic formula states then that x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. We would get the opposite of negative 4 plus or minus the square root of b again, which is negative 4, and be careful to put that in parentheses. Negative 4 quantity squared minus 4 times a, which is 3, times c, which is negative 4, divided by 2 times 3. So simplifying, the opposite of negative 4 is 4, plus or minus the square root of negative 4 squared is 16. And then be careful here, a negative times a negative is positive, and 12 times 4 is going to be 48. And then that is all divided by 6. So we get, this is 4 plus or minus the square root of 16 plus 48 is 64 divided by 6. And the square root of 64 is a perfect square, so that simplifies to be 4 plus or minus 8 divided by 6. So therefore the solutions are 4 plus 8 divided by 6, which is 12 divided by 6, or 2. Or x is 4 minus 8 divided by 6, which is negative 4 divided by 6, or negative 2/3. So the solution set would be negative 2/3, 2. Let's look at another example. If we have x squared plus 3x minus 1 equals 0, this is in standard form. So a would be equal to 1, b is 3, and c is negative 1. Substituting in x equals the opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2a. We would get x is equal to the opposite of 3, plus or minus the square root of 3 squared, minus 4 times a is 1, times c is negative 1. And then this is all divided by 2 times a, or 2 times 1. Simplifying, we get in the numerator negative 3 plus or minus the square root of, let's see, 3 squared is 9. Negative 4 times 1 times negative 1 is going to be plus 4, divided by 2 times 1 is 2. So we get negative 3 plus or minus the square root of 13 divided by 2. And the square root of 13 cannot be simplified, so we would just leave it in that form. You could write them as separate solutions or as this compact form as well. And then we'll do one more. 5x squared minus 2x equals negative 3. So we write that as 5x squared minus 2x plus 3 is equal to 0. To put it in standard form, and then a is 5, b is negative 2, and c is 3. Be a great idea if you want to pause the video and try to work this out on your own, and then return when you're done to check your work. So let's see. We would solve this by plugging into x equals opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2a. So x is equal to the opposite of b, which is opposite of negative 2, plus or minus the square root of negative 2 squared, minus 4 times 5 times 3, And that's all divided by 2 times 5. So x is equal to positive 2 plus or minus the square root of negative 2 squared is a positive 4. Negative 4 times 5 times 3 is minus 20 times 3 or minus 60. And then divided by 10. So this simplifies to be 2 plus or minus the square root of negative 56 divided by 10. And then we need to simplify this radical. Notice that because of the negative sign, we're going to have an imaginary number, but also, let me write this up here, square root of negative 56 is really the square root of negative 4 times 14. And the square root of negative 4 is 2i on the square root of 14. So this simplifies to be 2 plus or minus 2i on the square root of 14 divided by 10. And then we can actually simplify if there's a common factor between the numerator and denominator. And notice that there's a 2 common in the numerator, and 2 also goes into 10. So we can divide each of these terms in the numerator and then the denominator by 2 to simplify this to be 1 plus or minus I on the square root of 14 divided by 5. And so that would be my solution, and we can write those in the solution set notation. Now notice that in this case we had two imaginary solutions, and that was because the number inside the radical was negative. In the two previous examples, notice that in example A we actually have 2 rational solutions. Rational means that the number can be written as a quotient of 2 integers. But those are real numbers, they're rational solutions, and that's because the number inside the radical was a perfect square. And then in part B, we had 2 irrational solutions because the number inside is a positive number, but it's not a perfect square. So there are 2 irrational solutions. Right, if we looked at their decimal value, it would continue on and on and not in a repeating pattern. And so that number inside the radical is actually an important number for a quadratic equation. It's called the radicand of the quadratic formula, this b squared minus 4ac, and it is the discriminant of a quadratic equation, and it tells us the types of solutions that an equation will have. So if we know what b squared minus 4ac is, we know the types of solutions. If that number inside the radical is a positive perfect square, then just like in example A, we had 2 rational solutions. If it's positive but not a perfect square, we have 2 irrational solutions. If it happens to be 0, well, remember there we would have minus b plus or minus the square root of 0 over 2a, but plus or minus 0 is just one value, right? So we would just have one repeating rational solution. And then if it's negative, we're going to have 2 complex or 2 imaginary solutions.